In this problem, Takashi has a smartphone which has a capacity of n. At time 0.5, 1.5, 2.5, and so on, his battery charge goes down by 1. He will leave his house at full charge and then he'll visit M cafes. And then at time t, he will come back home. When he visits each cafe, he will stay there from time interval AI to BI. And while he's at these cafes, he will charge his phone so the battery will go up by 1. Uh, we just want to find out whether it's possible for Takashi to make this whole trip without his battery charge going below 0. And also one more key thing to note is when he's at a cafe, his battery capacity can't go higher than n because that's the maximum capacity. So yeah, first thing first, let's just read in the inputs int n empty. So n is the max capacity, t is the time he comes back home, and m is the number of cafes he visits. So the maximum capacity is n, and we also want to keep track of the last cafe he was at. So initially his last cafe would be non-existent, so we'll just keep it as 0. So we now read in the A's and the B's that were given. So int A, B, C, and A, B. And now we want to keep track of how much battery he's lost. So from the period from the last cafe to the cafe he's currently entering with this A and B value, he will be losing battery. So the loss of battery will be the same as A minus the last cafe, right? So it's the time he enters his new cafe. The battery will be lost from the time he left the old cafe until the time he enters this cafe. So that's why it's A minus last cafe. So let's change the value of n, which will be his current battery capacity. So in this time period, he will lose a lost amount of battery, right? So if the value of n ever becomes less than or equal to 0, then we know it's impossible. So let's just make a variable for impossible and just initially we say it's possible. Over here we know it's not possible. So now when he's at the cafe, the amount of charge he earns back would be B minus A. So he entered the time A, he leaves at time B. So in the time interval of B minus A, that's the number of points back he gets in his battery. So now the key thing to notice is when he stays at a cafe, the his phone can't have a charge of higher than n, right? So therefore we have to ensure that n is the min of what the current value of n is and the maximum capacity, because it cannot be higher than the maximum capacity. So yeah, and after we do that, we just have to ensure that this is now the last cafe, and we set the time as the time we leave this cafe. So now that we have done that, this now is at the point where we have gone to every single cafe. So now what we have to do is now from the last cafe go home. So then from our current battery value, we would subtract t minus last cafe. Oops. And now here we just check again if n is less than or equal to 0, then impossible equals 1. And then if it's impossible, we output no, otherwise we output yes. Yeah. So we just have to break this down into steps. So the first thing is we have to visit every cafe, and then once we visit the cafe, we have to go back home. So that's why we have to do this last part. Oops. and this should be, and voila,